All right. Hi, everyone. I'm Anshul, CEO at Neaupeak Robotics. Today, agriculture has a huge labor problem. Even with rising minimum wages, over 70% of farmers cannot find enough people to work on their fields. And this problem is nowhere as bad as it is with strawberries because they're one of the most labor-intensive fruits you can pick. So much so that most North American farmers today are dependent on seasonal workers from other countries like Mexico. They have to pay for their flights, their visa, their food, their accommodation, and even after jumping through all of those hoops, they are still forced to let some of their crops rot in the fields, then have human workers go pick through them because human labor is just that expensive. Last year, over $3 billion were spent just to pay human workers to pick every single strawberry that you bought at a store. And this is a story that's not just unique to strawberries. It's repeated across the industry, be it tomatoes, raspberries, blueberries, you name it. So we think the right solution to solve this problem of chronic labor shortage is to deploy a fleet of fully autonomous and intelligent robots. Our robots are equipped with most cutting-edge advances in artificial intelligence that allows them to not just pick the fruit, but scan the plants and provide farmers with intelligent insights about their crop health. Not only that, these robots are capable of picking at night, which increases the shelf life of the fruit and allows farmers to ship their fruits further and gain higher profits for the same fruit that's picked by our robots. Now, we don't just want to make a strawberry picking robot. We want to make a labor automation platform. And to do this, we have vertically integrated every core component of our technology from ground up. This includes our patent-pending HumanX robotic arm that has 7 degrees of freedom. That's the same degrees of freedom as a human arm, which means that these robots can not just work in outdoor fields, they can go into indoor greenhouses without requiring any hardware changes. It also includes our fruit detection AI, which has state-of-the-art performance, human-grade performance, and at the same time can detect 4 different grades of ripeness. Our intelligent plant and health analytics platform that allows the robots to scan the fruit and allows farmers to predict their yield and save even more money in the future. And finally, a patent-pending universal soft gripper that can pick more than just strawberries. And finally, a self-driving intelligent AI that is capable of working safely alongside other human workers on the field. Now, we will generate revenue on this by offering fruit picking as a service to make the adoption easier. We'll charge a fixed price for every pound of strawberries picked by the robot, and this is the only upfront investment required by the farmer to get the robots onto their fields. This will give about 15% reduction over the current labor costs that the farmers have. And let me repeat this again. The farmers do not pay us anything upfront to get these robots onto the field, so 0 payback period for the farmers. And because of this affordable swarm robotics approach we have taken, we can make sure that these robots can pay themselves off within just 4 months of continuous operation onto the fields. In addition to this, we give farmers intelligent insights about their crop health that allows them to be more proactive about the health of their crop. And because these robots can work in indoor greenhouses, we can make sure that they are in operation for the entire year and not just for the few months of the year when strawberries are in season. Now, the idea of using robots to pick strawberries is an obvious one. And what you see on the left is the approach that most of the industry seems to have taken, building large mechanized machines that use industrial-grade robotic arms that are meant to plug into a wall and go in a car factory. And because of this, these robots are extremely bulky and expensive. They are very expensive to transport as well, which means they are only meant to work in large outdoor fields. And most of the fields in New York are small to medium size, so these machines are not meant to would not work in any New York fields. At the same time, because of how bulky these machines are, if one thing breaks in the machine, the entire machine stops working, which reduces the reliability. And sometimes farmers only get 2 or 3 days to pick their crops, so this is a big deal for the farmers. On the other hand, with our approach, we can make sure that our robots can not just pick on the outdoor fields, they can go into greenhouses. At the same time, we can make sure that these robots can scale up to meet the needs of large farms and scale down to meet the needs of small to medium-sized farms you will see in New York. And if one robot fails, no big deal. The rest of the fleet continues to work, which gives more peace of mind to the farmers that work with us. Now, this intelligent approach that we have taken allows us to think beyond just strawberry picking. Strawberry harvesting is our first stepping stone, but we want to follow that soon up by our CropSense AI subscription service, and soon with a greenhouse tomato harvesting service, and eventually harvesting other crops like apples and automating all manual labor tasks on the field. Now here you can see our robot picking at night. Because of low temperatures at night, these fruits have higher shelf life, which allows farmers to ship their fruits further and gain more profits. And this is one of the reasons why they love us when we are on the field picking for them. And that's the very same robot that you saw picking on a field, picking strawberries in an indoor greenhouse. And from what we know, we are one of the world's first robotic platforms capable of working in two entirely different environments with the same hardware. And finally, this is that very same robot that you saw picking strawberries, picking tomatoes in an indoor greenhouse condition, further proving the flexibility and the intelligence that we have baked into our hardware here. And we have moved incredibly quickly for a hardware company. We have already conducted several pilots with some of the largest berry growers in Canada. We have secured over $400,000 in research grants and competitions. And we have a pilot in California planned this month. We are also partnering with one of the largest tomato growers in North America. We already have 3 letters of commitment, 22 growers on our wait list, and they all want this machine on their fields as soon as possible. And to do this, next year we are building up a fleet of 12 robots and commercially validating our technology on the fields. And we do all of this while making sure that we are a hardware company with software margins. How do we make this possible? We make this possible by making sure that these robots are made to be busy for the entire season and the entire year. We can move our fleet, because of how small these robots are, within the same day to different fields, thus making sure that the utility of the robot remains high and our profit margins remain high, and the numbers speak for themselves. We have partnered with some of the largest growers in both outdoor fields and indoor greenhouses on the West Coast, and now we want to use New York as our launchpad for launching this technology on the East Coast. We think New York is a great region for us to be in because it allows us to be in the region with some of the most high technology indoor climate control greenhouses in the world. We have received significant interest, including from Intergrow Greenhouses, their letter of support, which they happen to be one of the largest indoor tomato growers in North America. And we have partnered with some of the largest, partners to help us assemble our robots in the region. Finally, we have received significant interest from Cornell University to partner with us to get these robots into the fields. If we win $1 million, we'll be working on at least 3 different projects with them, and this is proven by the letter of supports they have written for us. We'll be working on CropSense AI service to make it more modified to be better fit the needs of the farmers in New York, pest detection service, and a UV disinfection service, and finally, apple harvesting trial with our robots in the region. And we do all of this while making sure we create 60 high-caliber, high-quality jobs in the region. These jobs will be engineering, research, and development jobs in the region. This includes also our local supply chain partners that we'll be working with to manufacture using 3D printing, arm manufacturing, robot-based manufacturing, electronics assembly, and finally, we'll also be training and operating our team of robot technicians onto the field. These people will be trained to not just operate the robots with our customers, but actually making sure they know how to manufacture and maintain these robots in the region. Now, I'm an immigrant myself, and we have built a great team here. Our core management team has 40% representation for female gender, and at the same time, our team as a whole has 60% representation for visible minorities. I'm very proud of the team we have built here, and we plan to keep it that way as we go forward in the future. We also have a great team of advisors that have supported us over the past 3 years we have been in operation. Together, they have over 85 years of experience in ag tech, robotics, navigation, crop sciences, and some of them have had successful exits with some of the largest ventures in the world. So we are very excited to bring these robots onto the farms in New York and make sure that New York remains competitive with the world when it comes to precision agriculture, robotics, automation. And I'm very excited to bring these robots in the region. So if you think this is the future and you want to help us feed 11 billion people we'll have in the world by 2050, please come join us on this journey. Thank you.
Well done. Great job, Anshul. I want to welcome Alex up.
Yeah.
Alex Moret will be joining. Okay, we have a sharp 10 minutes for questions. Over to you, Laura, for the first question.
Well, I'm the farmer, and I would love to see these things out in the field. I think that would be so exciting to watch this happen, and I can see that in the future we will be going more to robotics. There's no choice because there just won't be enough labor. It seemed like these things went slower than what a human picker would be picking in a strawberry field. Is that just because you were showing it, or is that the normal speed? Would you need like 20 of these to get through a field on time, or what do you envision in that kind of thing?
I think I can talk about that. So this is like a comparison between a human worker and our robots. So you're right, these robots are slow right now. We are continuously improving their speed, but right now they work at about 60% the speed of a human worker. But the fact is that a human can only work for 8 hours a day, but these robots can work 3 times as much in the same day. So overall, if you look at how much output they have over the whole day, these robots end up doing more work than a human worker.
And do you see having a lot of these available in fields? Because many of these seasons, like strawberries, are pretty short season here, and you know, you'd have to have quite a few of them in order to get through all of the strawberry fields.
That is true. Yes, there will be a lot of them. So approximately one harvester, robotic harvester here, is replacing one human worker. So that will give you some context for how many robots we'll end up needing. But the idea is that the whole reason why we have worked so hard on making our own robotic arms when we can just buy something off the shelf is because we can make sure these robots are kept busy the entire year. So even if the strawberry season is short in this region for only 2 months, we can make sure these robots can still be brought here and operate profitably, because we can take these robots and make them busy for doing something else the rest of the year, which is something that no other company in the world can speak of. So we are the only ones that can work with such short seasons because of this approach we have taken.
Great. I think you're up next, John Ang.
Really cool. I'm glad you brought one over here. I want to come up and touch it.
It wasn't easy.
Amazing stuff. I'm just amazed by it altogether. But tell me, if you're trying to adapt this for other farmers, actually, does the farmer have to adapt some of their growing techniques to use this?
Yeah, no, they don't have to change anything. So we've kind of designed to be able to work in all fields, and kind of every field is a little bit different, whether it's in BC, New York, or California. And so we took the approach where we looked at all these farms and figured out the proper base that would work for all of them. So part of when we go to a farm, we're partnering with them. So we see what their operation is, see if we need to make any changes on a robot, which is very easily done because of how we designed it. And then we kind of adapt our technology for the particular farmer.
Yeah, like is there limitations? Like I'm in the Hudson Valley. Can this thing work on a 20 or 30 degree slope of an apple orchard?
Yeah, actually we were just in California where the fields were very sloped, and it can climb up the hills and it could do it. So that's part of our validation, why we want to see as many farmers as possible to make sure it works. And so far on slopes, I think it was like a 30 degree slope, we were able to move the robot up and down and pick in their field.
Great. I think we're jumping over to Annie next.
Yeah, I'd love to see it working, but that might be just a fantasy here. So when I saw it operating live, there's a lot of residual when you pick. So it seemed that the plants were shaking. Is there loss of product with this technology?
Yeah, the farmers said to us is, don't pick any unripe strawberries, only pick ripe ones, and do not damage it. And so if we go to and that's what they care about the most. If we leave it on the plant, that's okay. So that was the comparison that we really looked at. And so we'd rather not pick a strawberry than pick it if it's going to damage it. And so for comparison, we went, human worker picked it, then we went through and picked it. We left the strawberries for a few days so you can really see if there's any damage. And time again, the farmer would look at it and he couldn't tell the difference between both strawberries. And we've done that test. It's pretty much a test in every field and every new farmer we go to is we do that comparison test. So they believe in the technology and they see that it is really helping and it doesn't hurt the strawberry.
Great.
What I'm referring to, though, is it shakes the plant. So is there fruit that comes off that may go to the ground? I mean, that,
In fact, like one of the good things about picking a strawberry is that it's so firmly attached to the plant while being a soft fruit that no amount of shaking is going to get any fruits loose. That's the reason why there are no automated solutions available for strawberries just yet. So even though it shakes the plants, it doesn't really do any damage to the plants and doesn't do any damage to the fruit as well because of all the things we have baked into our gripper and the intelligence that we have in there.
that's not true for tomatoes. Tomatoes will fall off, so that's why you showed.
You're right, yeah. With the tomatoes, they are not as firmly attached, and that's why we can apply less force to pick them. So you won't see the same movement when we are picking tomatoes.
And you could, yeah, we've concentrated on strawberries, so in our timeline, we're commercializing in 2024 for tomatoes because we're still kind of in that trial stage. Strawberries, we're into the commercialization stage, and tomatoes, we're still working on that extra little bit for picking it.
Cool. Over to you, John Capiano.
Yeah, and I agree with my colleagues, and like Laura said, these robots, seeing them in nursery operations and things like that, greenhouse operations, it's just a matter of magnitude and when. So that's very exciting. My question gets back to some of your sales model. I look at you guys, you're scientists, you're smart guys building the robots and all that, and then you start talking about things like a service model, which to me then that gets into a whole world of with humans it's HR, but with non-humans it's piece rate, and how you get that out to the farmer. So how are you going to tackle that? Any plans to bring any non-scientists on board to help you?
Yeah, my background, I guess I'm a mechanical engineer, but business development and new technology is kind of where I've kind of grown, and I have my MBA for the rest of my career. So that's kind of like where I'm come into play. When we do talk to farmers, they like this service model because it mimics kind of how they're paying, like you say, with HR, and how they're already paying for the picking of their strawberries. So they like this model better rather than just selling them a particular machine. And yes, there will be logistics around for operating this machines and servicing them. Our first test, kind of the worst case scenario, is about 10 robots per operator that will be in the field. And then we've already started setting up logistic hub of moving those robots around and how we're going to maintain them as well.
Great. Let's run down to Mary for the next question.
Sure, just a very quick clarification question on this slide first before I ask my real question, which goes after that. But on here you have that there's, 640 pounds a day for a person working an 8-hour day, but we all know that they work more than 8 hours if it's long, right? Versus 720 pounds a day for the robot harvesting 24 hours a day.
That's right.
Right? So if the worker works more, then they can still outpick one robot.
It's possible, yeah. And each farmer has their own star pickers that they can obviously do more than the robot can do in a single day. But again, the landscape is changing very quickly. The minimum wages are rising, and at the same time, like this has happened in California, it's happening in New York as well, that farmers have to pay overtime now to their seasonal workers if they go beyond 8 hours. So I think the economics that we are quoting here would actually be even worse for human workers if you were to compare and include those costs in there as well. And again, like this 60 cents a pound doesn't include any overhead they have to get the human worker on their feet. So if anything, we are being conservative when we quote these numbers here.
Yeah, and they have to pay overtime for any 8 hours, so that's another thing to consider. I don't look at it as like a one-to-one fix because it's more of a cost. It always comes down to the cost of the farmer so they can grow more food and they can put more in it. So if the robot's cheaper, we have 2 robots per worker. I always try to distinguish one for one because you just add more robots if it's cost effective and the farmer's happier.
And so my real question was about the services model. And just thinking about how do you see that actually being deployed? Because one of the challenges is, farmers, they all need it at the same time. And your guys can, you can only be at one field at one time. So how are you going to kind of match the supply and demand issues around that as that business grows?
Yeah, that's a good question. It definitely is comes down to logistics at that point and why we can have swarm robots. So we could put 10 at this field. We know we've worked with a farmer. He has 100 acres. We need 20 robots on this day. We need another 20 the robot the next day, and we can move them around from field to field. Because we're small, we have the ability to do that.
Great. Well,